Now, to get to the whole love note thing, we kind of need a what happens if she says no kind of scenario, right? At least for me. Um, because all we've said so far is I only know what to do if the answer is true. But if the person says no on the little love note, checks the no box, what do I want to do then? So that gives us else. And if I use an if else block, it looks like this. You can see I have the if statement, the expression. This should have two, not not like that. My gosh, where'd that go? It was there before. There we go. If I'm testing for equality, right, I need to have the two equal signs. So if you like me equals true, then that's a yes, else no. So basically, if this is true, then do this. If it's not true, then do the other thing. So in my code, that allows me to do something a little bit more complex, right? I'm going to steal my own code, except it has smart quotes in there. If you're ever copying and pasting and you get all kinds of weird errors, pay attention because quotes that are directional, see how these quotes are a little bit different than these quotes? Your computer in your word processing program likes to put in smart quotes, but smart quotes aren't recognized in any programming languages. So be aware of that. Actually, I'm going to switch this up. I'm going to say yes or no. Okay, so something like that maybe. So here I have an if else where the person can check the yes or no box, and based on their response, if they say yes, then I ask them out. If not, I pretend like it was a mistake or I was talking to the person behind them or something. Um, so if I run that, that's an interesting thing, but it's always sort of predictable. If I want to create an interactive program that interacts with users, I might do something like this. And now every time I run it, I get a little surprise. It functions just like the love note. But it also doesn't work great because if I type anything other than yes, and in fact, if I type anything other than yes with a capital at the front of it, I'm having some issues, right? Even if I say, like, really excited yes, it doesn't recognize that. So that's a problem. That's not a great, robust program. So there are some things I can do there, right? I can I can take this and I could make it all lowercase, and then I could have my lowercase be tested there. I could also strip that. And there's actually, if I want to, a way that I'll show you where you can remove the punctuation. And so you're narrowing the possibilities. But here's a really practical thing, a non-programming, more psychological thing that you can do to help your users. And that is tell them what the choices are in the interface itself. If you tell the users what the choices are, it doesn't specifically limit them to those choices, but you'll find that the vast majority of users will actually choose one of those things, even if they're typing it in. So that's just a UI thing. I haven't done anything programmatically different. All I've done is use a little bit of psychology and what I know about user behavior to help people do what I need them to do to use my program successfully. And that's all user interface design is, really. So what we're doing here is we're not making the program user proof. We're not anywhere close to user proof yet. But what we're sort of doing is we're looking at what are the odds of a user incorrectly responding in certain kinds of ways. And we're trying to take the most common ways that users are going to respond poorly, the most common mistakes that they'll make in my program, and prevent those things. There's no way possible to prevent every possible user behavior that you're going to see out there in the world. But if you can get to like 90%, 95%, 98%, your program is going to be right up there with anything you'd buy from any manufacturer, Microsoft or anybody else. Because that level of user interface design and programming is what we would call an industry standard. Okay.